Hi, this is Dr. Andrew Chrysler, teaching electromagnetics at Idaho State University. This is the first in a series of videos where I'm going to be discussing finding normal vectors to a line as well as normal vectors to a surface. However, in this first video, what I'm going to be focusing on is finding a tangent line. So not quite a vector, but a line. So this series of videos is going to contain four things. First, finding tangent lines. Second, finding normal lines. Third, finding unit normal vectors. Fourth, finding unit normal vectors for a surface. I made this series of videos because after teaching electromagnetics for several years, I noticed that many students struggled with this concept, which ends up being something that you need to know for a variety of different electromagnetics problems, which is just looking at a three-dimensional surface or maybe a two-dimensional, like a line, and determining what the normal vector is. So let's get started by first discussing tangent lines. So if you have any function, in this case, let's take an example, f of x is equal to x cubed, we can find a tangent to that function, f prime, by taking the derivative. And so this is the derivative of that function. Now, for a specific point, so if we wanted to choose a specific point, let's say we'll choose x is equal to 2, we might want to find a specific line, which is a tangent for a specific point on here. Now, how would we do that? Well, we're going to need to get the slope of that line, which we can do by just taking our x is equal to 2, plugging that in here, substituting it in, and then evaluating, we get 12. And we can go on to say that the slope is equal to 12. And often we call the slope of the line m, which I've done here. So how do we take this information from the derivative and turn it into a line? Let's do that next. We'll use the point slope form. So what is x1 and y1? Well, we're going to use our original function. So our original function was x cubed, and we were saying, oh, we want to find a line that is tangent at x is equal to 2, right? So that's what we were looking at in this one, right? We chose that point. We wanted to find that specific line. So we evaluate at x equal to 2, and so we get at x is equal to 2, the evaluation of the function is 8. And so that gives us x2, x1 is 2, and y1 is 8. So this is a point, 2, 8, that our line must pass through. So our tangent line must pass through this point. This is the point where it's a tangent to our original function of x cubed. And so we can say that we want a line through point 2, 8 with slope of 12. Now we can substitute in what we know. So we had the y1, x1, and m, all of which we've just found. We can substitute all those in, and we arrive at this function, y is equal to 12x minus 16, which is a tangent line. I'll see you in the next video.